All right, so sometimes in textbooks or I guess elsewhere, if you're talking with people who are into this kind of thing, some people say something that like y varies directly as x, and what does that mean? What is the idea of direct variation? So the relationship between two variables, you know, x and y, or miles and hours, or I don't know, volume and temperature, uh, is called a direct variation if one of the variables is a constant multiple of the other, and actually vice versa. You can just rearrange the equation so it works the other way. But so if it's one is a constant multiple of the other, so for example, so it would look like something like this: y equals kx, where that k is just a constant, so a number like 3. So if we have this direct variation that says y equals 3 of x, that means y is always 3 times whatever x is, right? So it's a constant multiple, meaning um, if you take y, or if you take x and multiply it by 3, whatever x is, y is going to be x multiplied by 3. So y is a constant multiple of x. So that's why a direct variation has this form. So this would be what we call k. It stands for whatever that constant is. I don't know why it's called k. My guess is some German mathematician came up with this, and the word for constant in German starts with a K. But that's just my guess off the top of my head. Should have done research before I started this lesson, right? Okay, so this K is called the constant of variation. Okay, it's the constant that's kind of ruling this direct variation. So let us look at something based in real life. So I've got a table of values here. Um, Actually, this is in x. These are miles, and these are hours. Um, so if you notice this, so say like I recorded some values here. I'm driving away from, I don't know, this this deep pit of doom where there's monsters and untold horrors. Okay, I'm driving away from it. Sorry, it's early in the morning for me. I'm still waking up. I'm driving away from this pit of doom, and I'm recording. I'm not so scared because I have time to record what's going on. Um, so I record my distance away from the pit of doom um, every few hours. So after 1 hour, I notice that I'm tw um, actually, sorry, these are reversed. Time goes on the x-axis. Sorry about that. Okay, uh, hours, miles. Okay. After 1 hour, I notice that I'm exactly 20 miles away from the pit of doom. After 3 hours, I notice I'm 60 miles away from the pit of doom. After 7 hours, I'm 140 miles away from the pit of doom. And I just keep driving forever because I gotta get away, right? Um, well, notice something about how these variables, this time and distance, relate to each other. Um, if I take y and divide it by x, so we 20 divided by 1 is 20. 60 divided by 3 is 20. 140 divided by 7 is 20. So I could write this relationship. So I could say um, y varies directly as x, or the number of miles varies directly as the number of hours. And I could write this um, as miles equals 20 times hours. So 20 is my constant of variation. So uh, So distance equals speed times time. That's something that you'll see a lot in physics, right? Distance equals speed times time. Um, so how many miles have I gone? Well, I take the number of hours I've driven, multiply it by 20, and that's how many miles there are. So the number of miles is always 20 times however many hours I've gone. And this is the graph of this situation, right? What's the slope of this graph? Uh, 20. 20 miles per hour, right? So that's the rate of change of this graph. So here's an example of a direct variation, miles varying directly as hours, and the constant of variation would correspond to the slope of that graph. And by the way, graphs of direct variations will always go through the origin. Why? Because if my equation is something like this, it's set up something like this, whatever y represents, whatever x represents, and there's some kind of constant that defines a relationship, um, then so what at x equals 0, I would just plug in 0 for x. What's anything times 0? Who cares what the constant is? Times it by 0, and I get 0. So when x is 0, y is 0, because of the kind of the structure of this equation. So that's how you can eyeball a direct variation. Is it a straight line? Does it go through the origin? Boom. So there you go. Y equals kx, where k is a constant. That is called a direct variation, and the way it's kind of said in our language or written in a textbook, it might be like y varies directly as x. Sounds a little strange, but this is what they're talking about.